Dear all, welcome. The next topic which we are going to discuss is about X-ray machine, and we are going to analyze and we are going to discuss how the X-ray imaging has been done and what is the physics behind it. So to begin with, X-ray imaging we can also term it as projectional radiography, and it's a form of medical imaging that produces a two-dimensional image using X-ray as a radiation. And this picture shows the schematic illustration of how an X-ray imaging is being recorded. So we have an X-ray generator which generates the X-rays, and we have an X-ray tube which passes the X-ray towards a particular part of the human body which has to be examined. And on the other end we have the grid connected with the detector which detects the outcoming X-ray from the human body. So in medical application, the X-ray generators are used by the radiographers to acquire the X-ray image of internal structure, say for example bones of a living organism. So the structure of this apparatus, this equipment consists of X-ray generator, grids, detector, and finally we have a shielding. So this is yet another schematic illustration illustrating how X-ray imaging will be recorded. So we have an X-ray generator which passes the X-rays towards particular portion of which the X-ray imaging has to be recorded. So we have an object who will be asked to lie down between the X-ray generator and the detector, and in between we have a grid. The main purpose of the grid is actually to reduce the scattered X-rays. So the first one is X-ray generator, which is nothing but the Coolidge tube what we have studied in our lower class. So this X-ray generator is actually an X-ray tube, or it's a simple vacuum tube that consists of a metallic cathode which directs a stream of electrons, and on the other end we have an anode which collects the electrons, and we have a heavy metal target, and when the electron collide with the heavy metal target, that is tungsten, the X-rays will be emitted. So in which about 1% of the resulting energy is emitted as X-ray, and remaining 99% is released as a heat. The second part is about the grids. So this grid, or we call it as a Bucky-Potter grid, is placed between the patient and the detector, and one of the main purpose of this grid is actually to reduce the scattered X-ray that reaches the detector. So this is the schematic representation of the grid, where we can see linear lines of patterns which actually used to detect the primary X-ray and to avoid the scattered X-ray. By the presence of this kind of grid, it improves the contrast or resolution of the image and also increases the radiation exposure for the patient. And the third one is detectors. In general, the X-ray detectors are of two types. The first one is imaging detectors, and we call it as photographic plates, and the second one is dose measurement devices, say for example ionization chamber, Geiger counter, and which is used to measure the local radiation exposure and dose, etc., etc. And in order to obtain an image, the patient will be asked to lie down between the X-ray generator and the detector, and the exposed part which has to be examined should be placed between the X-ray source and the image receptor, and that produces a shadow of internal structure of that particular part of the body. So, and we can see here the X-ray image of the chest portion, and this is actually the X-ray imaging of around the neck portion. This X-ray, whatever we are making incident upon the human body, will be actually blocked by the dense tissues. Say for example the bones, the X-ray will not be able to penetrate through, whereas this X-ray will be easily penetrated through the soft tissue. as a result. When the X-ray strike and passes through the soft tissue, that region becomes dark, whereas the bones appears lighter in the surrounding. And the fourth one is about shielding. Shielding is actually to limit the radiation exposure depending upon the application what we require. So the dosage of radiation applied in radiography varies with procedure. Say for example, the effective dosage for chest X-ray is actually 0.1 MSV, while if you want to take the X-ray for abdomen, it is 10 MSV. And in general, a common example of shield against the X-ray is actually the lead, which has a high density of 11,340 kilogram per meter cube. And this tabular column shows the required thickness corresponding to the X-rays generated by peak voltage. An example, if it is 75 kilovolt, we need a thickness of 1 mm to act as a shield against the X-rays. Similarly, if it is 125 kilovolt, we need a thickness of 2 mm of lead to act as a shield against the X-rays. Likewise, we need 4 mm thickness of lead in order to act as a shield for the X-ray generated at 200 kilovolt. And this table is as per the recommendation of International Congress on Radiology. And finally, I would like to share some already recorded X-ray imaging available in the internet. So this first diagram shows the X-ray imaging of the wrist and around the hip region or the abdomen region, and X-ray imaging of right hand shoulder and X-ray imaging of leg portion. So this is how the X-rays has been recorded, and the doctor or the surgeon will be examining the affected part for further treatments. So thank you all. Thank you so much for your kind information.